Okay, this is take 2 on video 6. I tried to do this earlier today with a whiteboard in a classroom, and let's just say that nothing went right. That'll be the blooper reel that gets played in a happier day um, when this is all over, I guess. But anyway, this is video 6. Where I'm going to try to bring it all together. We're going to bring all these skills that we've learned so far in the course. This includes identifying these arguments, formalizing the statements, looking at the rules for arguments and the Venn diagrams. Ooh, and I almost forgot counterexamples. Don't forget the counterexamples. So it was a little bit understated. I didn't spend a ton of time on it. My way of sort of helping you work through arguments was to spend some time on the informal fallacies. And as we got a feel for those, we saw how arguments in general worked. That there is a conclusion that's usually preceded, at least logically, by premises. We try to find indicator words within arguments, things like since, because, considering, and so on indicate premises. Whereas words like thus, so, and therefore, and many others, lots of synonyms that you get a thesaurus open to find all of the possibilities for these, indicating conclusions. And so as we find our way into these much more structured formal arguments, the same skills still apply. Find the premise, find the conclusion. I think it's also useful to remind ourselves about our standard form statements. We have 4 possible types. If that isn't obvious to you, you probably need to back up to videos 1 and 2. But so we're just going to restate these here, where A is all subjects are predicates, where the subject is distributed and the predicate is not. And the 2-circle diagram looks like that. The E-form statement, no subjects are predicates, and both the subject and the predicate are distributed, and the diagram looks like that. The I-form statement, some subjects are predicates, nothing is distributed, and the diagram looks like that. Sorry, I accidentally made a stray mark there. I apologize for that. And then the O form, some subjects are not predicates. The subject is undistributed, but the predicate is. And remember, this not is logically equivalent to the no here. This is a negative part of the statement. It is not a part of the predicate. And the X belongs there. So we're going to keep that sheet handy. We'll have to slide it back into view once in a while. So with all that being said, let's start with a pretty simple problem, and we're going to work our way into some more difficult ones. So let's start by finding first the argument. Sugar is sweet and salt is not sweet, so salt is not sugar. And I would encourage us to just sort of, let's find the logic words that seem relevant here. Okay, so we've got 2 nots. an and a so. Those are words that are doing logical work in the statement. They don't have any sort of word meaning relevance, right? So what is the and doing? It's joining two premises. The not is negating in each case, and the so is indicating conclusion. Right? So then we're ready to start writing out our statement. The other thing we can see is that there's no indication of number here at all. So when we talk about sugar, generally, we're talking about all sugar. So we have all sugar is sweet. And the new premise, all salt is not sweet, so that not has to get put in front, so it's no salt is sweet. So salt is not sugar, talking about all salt and how it's not sugar. So no salt is sugar. Our forms are A, E, and E. The bottom line is our conclusion. So, and it never hurts to go back and check. Do I think I've got the intent of the original argument? Yeah, that looks pretty good. So now we might remind ourselves we've got an A form statement and two E form statements. So we're going to essentially draw this once, and then our conclusion should look like this one. When we transfer those two circle diagrams to the three circle diagram. So let's see if I can keep everything in one page. Well, we'll do one at a time. How about that? So we want the two circle diagram for this one. Looks like that. Both of these are going to look like that when we draw a three circle diagram here. So, all sugar is sweet. Well, first we've got to mark these circles. Salt, sugar for the bottom left and bottom right, and then the middle term sweet stays up here. So now we diagram all sugar is sweet. So that's this circle and this circle, like that. No salt is sweet. That would be these two circles now, kind of on this axis, right? So these two circles should look like this one. So no salt is sweet, empty that. And now we want to see, do these two circles on this axis look like that diagram where what's drawn here is for sure here. We got extra stuff, that doesn't matter. We want to make sure that the scribbling here matches the scribbling here. And I would say that it does indeed match. That's an indication that it is valid. Now, if we want to check our rules, we would probably want to remember what they are. So let's go through them. We'll just very quickly remind ourselves. The first rule is that you have to have three terms, each occurring twice. If you want to think about that as a well-formed syllogism, that's fine, but we satisfy that rule. Rule 2, middle term must be distributed at least once. So it might behoove us now to just mark the distributions here. And if you're not sure, you go, oh yes, I remember the distributions are exactly determined by the statement form. So an A form statement, always has these distributions. And two E-form statements are such that everything is distributed. And so now, is the middle term distributed at least once? The middle term is sweet. There it is there in the second premise, already distributed. Excellent. Rule 3. Terms distributed in the conclusion must be distributed in the premise in which they occur. Salt is distributed in the conclusion and it is in the premise. Check. Sugar is distributed in the conclusion and it is in the premise. Check. Rules 4 is you can't have two negative premises. We do not. Rule 5, if you have a negative premise, you must have a negative conclusion. Check. And rule 6, if the conclusion is particular, and it isn't. So it really kind of, we can almost think of it as it not being applicable in this case. And so I think we should be pretty heartily satisfied that this very simple argument is in fact valid. So now we get, we're not quite going to get quite political yet, but I don't know if you've noticed in the news that in fact the country of Ireland has noticed that the bread Subway puts in their sandwiches is pretty sweet, and so in fact they tested it and found it had lots of sugar, so much in fact that they decided it is actually more properly classified as cake. And what makes it interesting, of course, is that Ireland has a different tax for cake, which is considered a luxury, than it does for bread, which is a basic staple of life. So bread is tax-free, cake is taxed. And so if Subway is buying all this cake to make their sandwiches, then they pay more tax. So the government of Ireland is happy and the company Subway is not. So first of all, what's the conclusion? Subway bread, the word so helps us find the conclusion. Notice in this case we have a premise as a separate sentence. Then the second premise is the first phrase in a complex sentence, the conclusion of which is the second phrase. So notice a different grammatical structure than the previous example has the same logical structure. So now, how much Subway bread are we talking about? I think it's all Subway bread. Let's just use abbreviate whenever we can. Are, let's call it high sugar. Cake has lots of sugar, so all cake. If you're not sure why we're talking about all here, you might want to go back to one of the earlier videos where when we talk about formalizing individual statements. All cake are high in sugar. So all Subway bread is cake. Notice this really is kind of a flourish for language that really doesn't, well, let's actually notice. Suppose I said all Subway bread are really cake. Then when I check rule 1 and I say, do I have 3 terms occurring twice? I got high sugar twice, Subway bread twice, and I've got cake and I've got really cake. And it would be tempting to say, aha, 4-term fallacy. You're breaking rule number 1. It's important, though, to apply the principle of charity and say, look, this word really here is kind of a flourish. It is not denoting a different set of things than cake. There isn't cake. You wouldn't go into a store and say, I want really cake. You would buy cake. And are you sure it's cake? Yeah, it's really cake, right? This is a flourish that doesn't denote something different. So we want to just use cake in both cases so that we do obviously pass rule number 1. Since we've already started on the rules, let's continue. So rule number 2, middle term must be distributed at least once. So we've got all A-form statements. So the distribution is subject distributed, predicate is not in each case. And so now when we ask ourselves the middle term, that being the one that only occurs in the premises, not in the conclusion, it is not distributed in either case, and so we break rule number 2. We call this the fallacy of undistributed middle. Keep rotating my pen so that they don't dry out too much. Drawing the circle. We've got Subway bread, we've got cake, and we've got high sugar. Now we want to draw 3 A-form statements. All Subway bread are high sugar. Notice that this shows that there is nothing outside the circle of sugar that is the Subway bread. All cake are high sugar. And the fact that we drew on that section twice really is neither here nor there, although it might be a warning sign that maybe this argument is going sideways on us, because then we ask, does this show us, right, the 2-circle diagram we're looking for is this, where the set of things that are Subway bread outside of cake is empty. And notice we have this region here that is open when it should be closed. And so that shows us as invalid. Okay, moving right along. Venn diagrams are not logic, since everyone can do logic, but not everyone can do Venn diagrams. So, what's the conclusion? Well, I see 2 things that help us sort of understand the structure of this argument. One is the since. That tells us typically that stuff coming after it is reasons. And the other thing that we have here is the word but. But is kind of a weird word because, well, you know, because some people like big butts, but also because it really means the same as and, but has maybe just a negative connotation. I got nothing against butts myself, but some people think of them as negative. So we have, when we put all that together, we realize we have conclusion, premise, premise. So we'll leave the conclusion till last here. So since basically then we have everyone can do logic. So that's all people are logic doers. Next premise. Not everyone can do Venn diagrams. Now what does that, when we say not everyone, and you might even want to think of the not, and this is why we did direct inferences. Remember when I told you about contradictions? Ignore the not for a minute. Everyone can do Venn diagrams. We know what that statement would be. That would be all people are Venn diagram doers, right? So but now we put the not in front of it. We go across the diagonal to the contradiction, and it would be there is at least one person. Some people cannot do Venn diagrams. And now the conclusion, Venn diagrams are not logic. Oop, and I should say no. Venn diagrams are logic. Got to make sure I get my not in the right place. Now, when we check our rules, we want to say, do we have three terms each occurring twice? We got people twice. We got logic doers, and then we got logic. We got Venn diagram doers and Venn diagrams. What's going on here? Looks like not only do we not have three terms and not four terms, but five terms. And again, and what I'm trying to illustrate here is don't give up. Go back and work the problem a little bit. So maybe we've got the wrong categories. We're talking about people, and then we've got things people do, right? Venn diagrams are things people do. Logic is things people do. So maybe it is all things people do are logic, and some things people do are not Venn diagrams. Now we've got logic, Venn diagrams, and two sets of things people do. Notice to get into the pretty formal form of logic, we had to do this sort of mental gymnastics and find the right categories. Okay, so now we can pass rule number one. Notice you shouldn't give up when you find categories that don't work, because that would not be the principle of charity. Principle of charity is you gotta try to make a good argument whenever you can. Rule 2, middle term must be distributed at least once. So what's the middle term? Things people do. Well, it is distributed in the first premise, so that's good. Rule 3, terms distributed in the conclusion must be distributed in the premise in which they occur. This is an E-form statement in the conclusion, right? And so we look here and say, aha, both the subject and the predicate are distributed. So the Venn diagrams are distributed, logic is distributed. So now we look back and say, what's distributed in the premise? Some things people do are not Venn diagrams. That's an O form. Some subjects are not predicates, and the predicate is distributed. So Venn diagrams is distributed there. All things people do are logic doers. That's an A form statement. And so the predicate is undistributed. So aha, look, we've got a problem here. Logic is distributed, but not in the premise. And so it fails rule 3. That's the fallacy of illicit. And in this case, because it's the subject of the conclusion, it's the major term that's not properly distributed, illicit major. And if we want the 3-circle diagram, and I haven't left myself a whole ton of space here, we've got Venn diagrams, a little VD for you there, some logic, and then things people do. T, P, D. Now, all things people do are logic doers. Or sorry, all things people do are logic. All things people do are logic. Looks like that. Some things people do are not Venn diagrams. So no, some, we're drawing an O-form statement. We're putting an X in just the right spot. This is things people do. that are not Venn diagrams. So in this circle, but not in this circle, it has to be right there. It could have been in this region, except that's already been shaded. So it must be there. Now, does this show us no Venn diagrams are logic? Remembering, we're looking for a conclusion is an E-form statement. We're looking for this Venn diagram here where the cat's eye is shaded. Oops, sorry, I'm holding the right. This E-form here where the cat's eye is shaded. Cat's eye here, totally open. So that is not shaded, not valid. Let's get a little bit more complicated. Maybe I'll try a ballpoint pen and write a little smaller. If this doesn't work, then I guess we'll stop the video and edit it out. Okay. Okay, so we've got the logic word since and the logic word and. So that makes me think this must be the conclusion and these must be the premises. So now, and I'm going to abbreviate, I'll just going to underline the words that I'm going to use here. So I've got acts of free will. I'm going to say that is AFW, are uncaused events, UE, and mental decisions. And you'll find lots of textbooks when they're either giving answers or on, say, my answer keys on the Facebook page will use abbreviations that follow this general thing of the first letter of each of the words in the subject or the predicate. So we have all mental decisions. So that's all MD are uncaused events, UC, and all, the and is just sort of the carriage return almost on the statement, and all acts of free will are mental decisions, MD. Therefore, all acts of free will are uncaused events. Remember, we already figured out our conclusion was the first one. So we've got all acts of free will are uncaused events. Sorry, I didn't put a mark on there. Now, I'll make a couple observations at this point. Just by abbreviating a little bit and structuring this thing, we've already, I think, made some progress in understanding this argument. Even before we've done checking rules, looking at Venn diagrams, the shrewder among us, and I'm probably a little slower than average, might even have noticed that this is of the form of all A are B and all B are C, therefore all A are C, with just these two premises in reverse order. And then when you see it in this form, you go, you know what? I'm thinking this is going to be a pretty good argument. So I encourage you, as you to try to consolidate in the argument so that the structure, you'll see some textbooks bracket things off. If that's helpful to you, please feel free to do so. What that does is take all the all the meanings of the words that can get really complicated and sort of turn that aside. Because what really matters for these arguments is, do they work structurally independent? The MD could stand for anything you want at this point, right? A and B can stand for anything you want. This becomes just a straight up measurement of the structure of the argument. So let's check. Let's do the diagram first this time. So just another highlight on the blooper reel. Now the phone's ringing. So we have A, F, W, and U, E. I thought I'd turn that off. And then the middle term is mental decisions. Well, this will wake everyone up. Anyway, I was probably getting a little boring there. And we've answered the phone, and we're back. So just seamlessly edit. And I also, while we were off, I shamelessly raided my daughter's art supplies for some more markers. So here we are. We are doing all mental decisions are uncaused events. So we shade that out. And then all acts of free will are mental decisions. So we shade that out. And then we ask ourselves, does this show us that all acts of free will are uncaused events? What we want, of course, is that diagram showing that acts of free will is empty outside of uncaused events. So the shading here and the shading here is what we needed, right? You just imagine that third circle coming in like that, right? We needed this shading, and we have it here. So that looks valid to me. We check our rules super quick. Distributed, 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 undistributed, 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 because these are all A-form statements. And we can see middle term distributed once right there. Terms distributing the conclusion are distributing the premise which they occur. Notice that this one is distributed. This one's not distributed in the conclusion. We don't really even need the check up here, right? If this is undistributed in the conclusion, it could be distributed or undistributed in the premise. Either would have been fine. They don't have to match. It just if it's distributed here, it must be distributed here. If it's undistributed here, anything goes. Okay. No negative premises, so that's rule rules 4 and 5, and the conclusion's not particular, so that's rule 6. So that's an easy pass on those rules. Okay, which is exactly what we suspected because we recognize that this was, whether you want to call this transitivity in mathematics or the Barbara syllogism that we saw earlier. Right, this is something that's going to be pretty reliable. Okay, next one. No persons who plan ahead are persons who live in the present, since all persons who live in the present are satisfied people, and no persons who plan ahead are satisfied people. So we got some logic words to find. We got a no, a since, an and another no. We also could maybe, if we were being careful, we might say, you know what? We got some numbers here. We got right. Persons is that all is another number, right? So this is all universal. So this is going to be either A's or E's. There's no indication of any restriction here at all. So we're talking about all people who live in the present are satisfied people is the first premise. So it's going to be a form statement. And now let's persons who live in the present. So we'll just case a PWLP. Are satisfied people. And no persons who plan ahead people who plan ahead. We gotta be a little bit careful with our acronyms here. Are satisfied people. Therefore, going back to our conclusion, which was the first phrase in this thing, no persons who plan ahead, are people who live in the present, are people who live in the present. And you can see we've taken a lot of words and we've packed it into a nice tidy little thing here. That's also an E-form statement. What do you think? Valid or invalid? If we were in class, I'd take bets. It sometimes turned down to a bit of arm wrestling, but no such fun this year. Let's do the diagram first. So we've got PWPA, sounds like an airline that's about to go bankrupt, PWLP, their competitor, and satisfied people on the top. So now we diagram this. All PWLP are satisfied. So you know what? And since we got all these beautiful colors here, I'm going to do the shading and contrasting colors so it's just a bit more obvious. All PWLP are satisfied people, like that. And then no PWPA are satisfied people. So I'm going to shade like that. And I'm going to be looking for that kind of diagram, which is pretty much what I have here, right? This is a little extra shading there, a little extra shading there. Who cares? That cat's eye, that center part of that diagram is empty, just as predicted. So we think this is valid. Let's check our rules. So again, we just want to make sure that we have our distributions. Go back to our reference diagram. Right, so we have an A-form statement and a couple E-form statements. So subjects distributed in both, predicates distributed only in the E's. And so now rule 1, we're good to go. 3 terms each occurring twice. Rule 2, middle term must be distributed at least once. Check. Rule 3, terms distributed in the conclusion must be distributed in the premise in which they occur. You can tell I said that a few times in my career. The minor term is distributed properly, as is the major term distributed properly. Excellent. Rule 4, you can't have 2 negative premises. We have exactly 1. Rule 5, if you have a negative premise, you must have a negative conclusion. We do. Rule 6, not applicable, because, and we'll get to an example where that does apply in short order. So we think that's a pretty good argument.